Hello everyone, welcome to my channel. Today in this video I'll be proving a theorem which is arbitrary intersection of arbitrary collection of subgroup is also a subgroup. First, let G be a group. Then we will consider a collection of subgroup. We'll take it as H lambda, where lambda comes from index set. Where this sign represents index set. Index set means it goes from 1 to up to so on. So now, according to the definition, as non-empty subset H of G is said to be a subset H of G is said to be a subgroup of G if and only if AB inverse belongs to H. So first of all, what was the condition? Since this is already a subgroup, now we have to take the intersection. Now consider H, which will take H as intersection of H lambda. So since H lambda in this collection, all the H lambdas are the subgroups of G. So firstly, we know that it should be non-empty. So since H lambda is non-empty, we know that identity element belongs to H lambda, means the elements of this collection, which is subgroup, for all lambda belongs to index set. So E will belongs to the intersection, which means what we have considered the intersection to be H. So E belongs to H, which means therefore H is not empty set. Now let's consider A comma B belongs to H, which will imply that A and B belongs to intersection of H lambda, which means AB belongs to H lambda for all lambda belongs to index set. So now, since AB belongs to H lambda for all lambdas belongs to index set, and we know that each of the subgroup of the collection of subgroup is itself a subgroup. So since H lambda is a subgroup, it is also a group. So since AB belongs to H lambda, Then we will again recall the definition, which is, since we have already proven this part, so we will have to prove this part. So since H lambda is a subgroup of G, means it is also a group. So A belongs to H, then the inverse element of B will also belongs to H lambda. Which means if we operate A with B inverse, it will also belongs to H lambda for all lambda belongs to index set. Since it belongs, A B inverse belongs to each subgroup of the collection, so A B inverse will also belongs to intersection, which we have considered H lambda H. So therefore is also a subgroup. That's it for this video. Thank you.